Hello, everyone. Thank you so much for joining us today in this webinar. My name is Ava Mirpour, the BeCrop Advisor or BCA Program Coordinator Instructor from Biome Makers. Biome Makers is an ag tech company founded in California's Silicon Valley in 2015. Biome Makers is a global leader in setting the standard in soil health using BeCrop technology. Today, we have two panelists joining me on this call. My colleague at Biome Makers, Al Toops, who is our soil health and market expert, along with Steve Fent, regional sales executive at Hello Nature, and a recent BeCrop advisor. So congratulations on that, Steve, and thank you for joining us. Just a few housekeeping items before we jump in. As you may have noted, we will be offering CE units or continuing education units for attending this webinar. You will receive an email with a link to take a short exam of about 20 questions after the webinar, a couple of days after the webinar, which you must pass with a 70% or higher in order to receive your continuing education credits or your BeCrop Advisor certificate. So you will be getting both with that one exam. You will automatically become certified. So please be sure to keep an eye out for this email in the coming days. And this program is free of charge and grants you many benefits, such as access to our client management portal, which will become available to you once you recommend BeCrop to your first client. If this is the first time you have joined our webinars or heard about Biome Makers, you may be wondering, what is BeCrop to begin with? And the answer to that very important question is BeCrop is a proprietary DNA sequencing and intelligent computing workflow powered by the largest global taxonomic database of over 10 million microorganisms. BeCrop uses the soil microbiome as the bioindicator of soil functionality and breaks it down into three main categories: soil quality, health, and nutrition. BeCrop has been used in more than 40 countries worldwide to study farmland soils of more than 120 crops. In today's webinar, we will hear the first-hand BCA success story from Steve Fent and how he applies his certification to make informed and data-driven recommendations to the growers that he works with. We will then dive into several ways or angles from which BCAs can utilize various services based on BeCrop technology to bring significant value not only to growers, but to retailers, manufacturers, and even food companies that are committed to sourcing their produce from sustainable farms. So stay tuned for that at the end. We will end the session after a 10-minute Q&A at the end, so please feel free to submit your questions throughout the webinar in the questions section, and we will be sure to answer as many of them as possible. And with that, let's jump right in. Steve, Al, I'd like for you to introduce yourselves. Let's go ahead and start with you, Steve.
All right, well, thank you, and thank you everybody for joining us today. I'm regional sales rep with Hello Nature, and just to give you an idea, if you've never heard of Hello Nature in the past, it's a company that was founded in 1971 in Europe, formerly known as Talpolina, and in 2016 came to the U.S. and broke ground in Anderson, Indiana, on a biostimulant plant. In 2021, we celebrated our 50th anniversary, and at that point changed the name of the company to Hello Nature. Kind of fits more with the motto and direction that our CEO, Luca Bonini, would like the company to be and go. We are a leader in the biotechnology, biostimulant world throughout the entire world, because we're in 80 or 82 countries with 6 different manufacturing plants, I believe it is, throughout the world. And I've been in the agricultural professional products business for 30 plus years. A lot of experience with golf course and stuff. And the last 7-8 years has been with biostimulants, and we've never had a way to test anything with our soils. We always just had to guess. Came across Biome Makers about 4 years ago at a trade show in Vegas, met Al, and it's been a nice tool to be able to use to measure now what these biologicals do in the soils and find out what your soil microbial populations and ratios and everything are. And I'll turn it over to Al now and let him have his little say.
Thank you, Steve. Ava, thanks for the introduction. My name is Al Toops. I'm a soil scientist. I got my degree in agronomy from Oklahoma State. Been in the ag industry for 30 plus years as well, in various forms. Understanding soil biology is a major passion of mine, and being able to find a technology that can actually give us insights into doing that has been astounding. And we're now beginning to really dive in deep to use this technology as a tool to help improve the soil microbiome and what we can do to better influence biological inputs as well as others. Everything affects the soil microbiome, and so this is measurable with the BeCrop technology. So I'm glad to be here, and I'm looking forward to going through some of the success cases Steve and I have done together using this BeCrop testing. So what's up, Ava? We start?
Sure. Would you like me to start with the peppers? Would you like me to show those reports
Well,
right now?
I can tell. I'll start with a story. So,
Sure. Please
a little over a year ago, Biome Makers is, obviously trying to establish our footprint to make this tool available in the market. And our first license agreement with Waters Ag Lab in Camilla, Georgia, was a major influence in what we could do into the Southeast market, looking at cropping systems there. Waters now has the ability to do this testing in-house, and so they're our partner in the Eastern U.S. And so we're endeavoring to go into the marketplace with this tool in the Southeast. Steve had just begun to start a territory in Georgia, and so we were able to get some potential opportunities in a market that traditionally has very intensive cropping systems. So when you're talking about Georgia farmers, for the most part, they just do single cropping systems. A lot of those guys will grow as many as 7 or 8 different varieties of crops, and we ran across the potential opportunity with a pepper grower there that not only grows peppers, he's growing cotton and peanuts and cucumbers and a lot of other crops there. But in this particular high intensity farming practice, we wanted to be able to go in and show how we can take a problem case and see if we can identify the problems that they were faced with the BeCrop testing. So what we discovered there, talking to the farmers, was that for the most part, if you think about these Georgia soils, they're very sandy loam, low organic matter, and there's a lot of potential problems when it comes to nutrient availability. And we're talking about the cations especially. So what we really wanted to go after is to find out how we could better utilize products that we've tested, the Hello Nature products. We understood that we have potential there to be able to make nutrients available by biological inputs. But with the BeCrop technology, these are now, we're able to observe these improvements. And so the problem that we were faced with was calcium ability for the plant to pick up this particular cation, and it's unavailable for the most part. We did cases here. We looked at the total nutrient load of the calcium in the farm, and it was in an excessive amount. So I don't know what the actual number was. It was over 2,000 pounds per acre in the top 6 inches, but the BeCrop report showed low levels. So what I wanted to do is show the analysis we did in May of 2020. We came in, the first thing that happens when you see a BeCrop Plus report is the farmer says, well, I see that I have deficiencies when it comes to nutritional improvement or uptake. What do I do now? And that's where Steve comes in. We'll let him talk about the program that he put together for this farmer, and then show the improvements with BeCrop tests we did later in the year, and show the improvement not only in the biology but also in the nutrient availability. Can you show that report, Alva, the one we did in May?
Surely. I have them pulled up side by side right now, actually, but I can just do the main one. Give me one moment. And here we are. Can you see my screen?
Yes. So this is for those that haven't seen a BeCrop test, what we do is we break the report into 3 different pieces. We're looking at the biosustainability part, which we call that the soil quality portion. We changed this, was the old original reports were, we've changed that part now, we call that soil quality. And then we have a health and nutrition piece. I don't want to go through the whole report. I would gladly do that after this call with anybody that wants to go through it. But what I do want to show is the highlights of what we were looking at here, which was the nutritional piece. And we have an index on our report that shows very low as a bright yellow and very high as a dark blue. So if you don't mind going to the nutritional part of the report,
Absolutely.
and we can show that what we're measuring here is the biology associated with these nutrients. Go up just a hair. So we're looking at carbon, nitrogen, phosphorus, potassium, and then these 8 minor elements below. And as you can see, up just one, look at the nitrogen pathway. Just up.
Nitrogen up here.
Right down right there. So the nitrogen pathway was very low when we did this sample. Pathways of phosphorus, potassium were low. If you go down and look at the other minor elements, you can see that the zinc pathway was very low, magnesium low, very low, and calcium. And this is where the farmer was actually saying that if you can fix my calcium problem, you can really influence, you can really have an impact here. So what I want to show is if you look at the Malic 1 below this, go roll down just a little, you can see that the organic matter was 0.43%, and then we had a very high phosphorus level of 258 pounds per acre. And what we were focusing on here was potassium, or the calcium. Let's see what the calcium number was, Ava, if you don't mind.
Right.
Roll up just right here. You can see that we had 1,150 pounds. So once he saw that, and he says that I have calcium, but it's not getting in the plant. And usually we can do this by looking at sap analysis, which in tissue analysis as well, but Waters also does sap tissue analysis. We can measure the input and the impact of nutrient uptake by looking at sap analysis through the season. We in this case really wanted to measure the nutritional available in the soil. So if you Steve, what was the program you put in place here when we talked to them about this calcium problem that we wanted to try to correct?
Well, we began by, because these were transplanted peppers, we inoculated them with EcoVam in the greenhouse and a little bit of our peptide product, the Stimtide. And the EcoVam contains mycorrhiza, trichoderma, bacteria, and some of the peptides from Trainer. And peptides are an amino acid in a peptide form, which is a chain of amino acids. Just to explain what that is, when I use the word peptides, it's derived from a plant that we extracted out in a specific double enzymatic process. So it's very, very easy on the amino acids. So you have things like tryptophan and stuff that don't die off like they will with other chemical hydrolysis. And so we inoculate them in the greenhouse because of the transplant shock, and we wanted to cover that. We got into the field. Now these were fumigated fields, so the whole biology was pretty well stopped, which is like what you saw in that report. That was after fumigation, that it not only takes out the pathogens they want to take out, but unfortunately it takes out the good microbials too that you want for your nutrient pathways. So we inoculated everything in the field with EcoVam and a sugar product. Ours is called Vegemin that we use there. And then came back a month later and did the same thing again after the first application was at transplant. Second application was a month later. We then tested again in July. I believe in July was a second test. It was a 3 months later anyway. And these peppers had gone through over 50 inches. I believe Brandon said it was 50 inches of rain through this whole season. It's just been a horrible time in Georgia as everybody from that region knows. It rained all the time, and it just was incredible. And a lot of fertilizer in these crops, these vegetables, are done through fertigation. They were not able to run their fertigation hardly at all, and all the nutrients are put through that. Very, very little of them are sprayed. So when you go to the second test, you'll see the results.
Mm-hmm.
Can you show that, Ava, what we showed in?
Yes.
So
This is the second one, and I'm gonna get rid of this little toolbar over here so that you can see. So this is the second one, and I'm gonna try to get this one back up to be the same view.
What I want to really focus on, and Steve will follow, is go down to the nutrition. Well, actually, we saw some improvements not only in the nutritional pathways. We saw improvements with the with plant hormones and stress adapters too,
Yes.
and that's another piece of our health. So we went from measuring low indexes. Let's go to the hormone piece first, Ava, if you don't mind.
Surely.
On both reports. So you can see here that what we're looking at with hormone production in September versus hormone production that we saw when we did this particular lot or field in May. We went from auxin production of low or very low in this case, cytokinin very low, and gibberellin was medium, to where we improved the auxin, cytokinin, and gibberellin uptake or index here to quite substantially. Now, what we're measuring with the BeCrop test isn't the actual enzyme. We're measuring what we call biomarkers, or the identifying organisms in the soil that we can measure to show these particular enzymes that are part of the plant exudate. The stress adapters as well. When you look at the stress adapter in the soil, when we're looking at exopolysaccharides, heavy metal solubilizers, salt tolerance, cytophore production, ACC deaminase, salicylic acid, abscisic acid. You can see on the left when we did the original sample, the biology associated with these was quite low. Now we're able to improve these, show the improvement. So what we're able to do now is actually show that salicylic acid in this case went from very low to non-observable. This is it's like aspirin in the plant. If the plant is secreting salicylic acid, that particular hormone, it's like aspirin. You'll see it in a stress case is very high. If it's low, if the plant is growing at its potential and it's performing better, it's going to show as a very low index. So these are very good reports to see as a comparative tool. And then you look at the nutritional part. What we did see was these pathways. So you look at nitrogen in this case, we went from, now our report style had changed a little
bit,
but we went from very low to low, which was a major improvement. But what really improved, now we're looking at the biology that solubilizes and makes these nutrients available. And you can see the three indexes we look for in nitrogen cycle. But if you look at phosphorus and potassium in this case, the organisms associated with the movement of those nutrients went from low to medium, or went from low to high. And then the one that was really showing itself was the calcium pathway. So we had improvements there with calcium went from very low to low in just a short period of time. So now we see the effect of what the biological population is doing with the inoculant that the BeCoVan provided and the food sources that Brandon was putting in. But the astounding part of this report was now we can measure the available nutrients. So they're unavailable. So if you look at the Malic 1 test below, and if you look at the improvement that we saw with organic matter, the improvement we saw with phosphorus, for instance, we went from 258 pounds to 427. The improvement we saw with potassium went from 90 to 128. Now he's adding these nutrients, so we didn't want to really kind of just focus on that as much as we wanted to show the calcium pathway, because that was the target. That's the one we really wanted to improve. If you go down a little, go up just a little, Ava, you can see went from 1150 to 1650. So that 500 available pounds per acre, 502 pounds per acre of calcium that we know is available in the soil as an untapped resource. And what we like to do now is say, how can we use biologicals to go into a farming cropping system and find these unavailable nutrients? And that's why I like it. And Waters does this test. They can do a complete total digestion test. It can show you the unavailable nutrients. Now come in with a biological input, be able to mine these nutrients out, and now show them measurably with a conventional soil analysis and show what available nutrients are there. So when we saw what we're doing now is that we have an untapped source of calcium that he didn't have to buy from the supplier. He was able to mine his own from his own farm by using a biological input. It was a substantial proof that now we can show this technology to better understand how we can utilize current nutrients that are there in farming and cropping systems that we traditionally never could get before with the BeCrop technology. Now we did a little spreadsheet. Do you have that, Alva, you can show?
Yes, right here.
And you don't have to show it by itself. What I wanted to prove here was that with these two results on this particular farm, and we did a lot of sampling on this farm, but we wanted to really show the total improvements. If not only the colors represented here are the indexes we have on the BeCrop test, and then the nutrient differences are what we found with the Malik 1 completes. And you can see at the bottom in green there that what the improvements were in nutritional. We went with phosphorus at roughly 169 pounds, potassium 38. Sulfur didn't grow up much, but the calcium was a substantial increase. Magnesium 5. The only two that didn't change much was iron and copper. So this was convincing enough to where what traditionally biological products have entered into the market without having a tool to measure their effectiveness have kind of been thought of as an add-on to a conventional cropping system. We think now with the BeCrop technology and our BeCrop test, you can now actually use these products, these inoculants, biostimulants, other sources of biologicals now as an actual tool to be able to improve your nutritional uptake with nutrients that you have in your farm now that are unavailable, that now we can measure and show that they can be available.
Al,
I think what Steve has also is he did some corn examples too that I'll let him go through.
Al, before you go on, also they do tissue and sap sampling on these, and their nutrients stayed up in the sap and the tissue tests for the whole season. So they've always had trouble getting that calcium into the plant. One of the things the peptides do is help translocate it into the plant up and assimilate it through the plant. But by making it better available and opening that pathway, we got that calcium into the plant at a greater rate than he'd been able to do in the past. But he tested that and proved that from his sap and tissue testing. And same with the other nutrients. So I wanted to bring that out, that in the soil was a good, but in the plant was just as good.
That's great. That actually is a great measurement. Once you open these pathways up, you can actually begin to see that. I did a success case a number of years back when I first came to Biome Makers that we were looking at tomatoes and the effectiveness of an input of a biological and measuring the nutrients. When we did the BeCrop test originally, and we got to the field after the tomatoes were up to, I don't know, 4 or 5 inches in height, we did the tissue sample with a BeCrop test. And it was amazing to see the correlation between the tissue analysis and the BeCrop test. Once you begin to open these nutrient pathways, it's measurable with the sap analysis and tissue samples. Sap is more effective in a sense because you see an immediate result. You see what's moving quickly. Tissue samples, you're seeing nutrients that are stored in the leaf. So a lot of times they'll do an old and new sap test to measure the difference between old tissue and new tissue to see those effective nutrient differences.
Awesome. We have a couple of questions actually that are relevant to what we've been going over on these reports. If that's okay, I'm gonna ask a couple of them. I don't think we can do all of them right now, but a couple of them that I think are really important to note. We have one that says, great information. Could you explain the reason for the improvements of the nutrient pathways?
So what we're measuring now are these organisms specifically with our test, with the BeCrop test. We're looking at the soil biology. So we went from a deficiency to, but with an inoculant and a food source. So the way those organisms work that the EcoVam was putting in was once Steve recommends a food source, obviously, when they do inoculate, when they do put these this inoculant in the soil, but once they're established on the root hair, then the plant produces the energy to keep those organisms alive and to populate. So what we're able to do now, I mean, you just think about it, the amount of exudates coming back down into the soil and producing carbohydrates to feed the biology is phenomenal. They estimate that the energy produced by 1 acre on the top 1 inch of soil is equivalent to 10,000 people doing the same thing. We have this untapped resource of power that if we feed it can actually mine these nutrients that were unavailable and make them available. So what our BeCrop indexes show is we're showing carbon, nitrogen, phosphorus, potassium, and then we have 8 minor elements. Each of those functionalities are measurable with our test. So we can find these, we know the functions of those calcium solubilizers in this case that are making unavailable sources of calcium available to the plant with biological impacts. So that's how so Steve has the inoculant and we grow it with the plant.
So Al, just to also share, the only reason we knew what our product should do in the soil, and then this was to back it up, was we had Biome Makers do a product test, and it came back showing that it was very effective, or should be very effective, at opening the pathways in the NPK and the micronutrients, the hormones, and stress adapters. But that was by a BeCrop
product
test. Am I correct on that?
Product test, yes.
So that's how we started all this 3 years ago, by testing our product, and then because of the different species in it and the right ratio, they're all natural to the soil. So there's not anything that you're adding, in case anybody's afraid, of putting something that's going to fight against your native microbes. These products are basically your native microbes already in a spore form, not a liquid form. And that's one of the reasons we were able to tell what it might do. And then we were able to prove it with report after report.
And even though we were focusing on calcium in this case, the EcoVan is broad spectrum. So what was good about it is it has a good family of organisms. I don't know the actual count, Steve. You know what they were in your product, but what?
It's like 51.
Yeah. So what's so good about that is they're not. We like the idea that it helped the calcium solubilizing, open up those pathways, but nitrogen, phosphorus, potassium, all the elements were benefited. All these organisms were benefited with the improvements that we saw with the BeCrop test. So that's how we want to use this technology, is to be able to do measurable soil samples in the spring before planting, mid-season after planting, and then our portal that Ava will kind of explain more about is that we now have this tool where you can show this measurable improvement in your soil microbiome with our phenomenal tools that we offer with BeCrop testing.
Yep. So Al, that was fields that were fumigated, so that most of the microbial life was gone. The next trial that we're going to show has to do with actual row crop fields, a cornfield. Every other year it's had hog manure put on it, and this is actually a decent yielding field. Prior to the applications, it was an acceptable field for the farmer. 265, 270 bushel of corn, nothing bad. But and he thought this was really a healthy field because he'd been putting hog manure on every other year, and it's decent quality. So I'll let you, Al, go through this first report on the home east on the left side, our beginning in April, and then after one application of Ecovam and the sugar Vegemin, what we found to the pathways in a corn situation where it's pretty much no-till or light till.
Okay. So the samples were pulled into April here, looks like, and this summary shows the lot of yellow in the report, as you can see. One area there we looked at nutrition is dark blue, but overall the pathways for nutrients, and let's just kind of go through this stuff if you don't mind, and we'll just kind of run through the report here to show the impacts of what we're looking at when we look at biosustainability, which really improved, which is an overall view. So let's, as you guys have heard by now, the index that we show is dark yellow being a low index and dark blue being a high index. So you can see here that when we looked at the biodiversity of this cropping system, that we went from, in the case here of low biodiversity, meaning the functionality of the organisms working together in a unit. When you think about nature, the way biodiversity works is you'll have a population, let's say, for instance, in a city, and each of the people in that city, or each of the functions of the town, you have a post office and a grocery store and a school and fire station and all these different things. We want to make sure that that the biodiversity is well robust and working well. And if it's not, if it's influenced by particular tillage practices or impacts of farming practices, then you end up with the low functions of the biodiversity. It becomes segregated. It becomes more not available to do multiple functions. And that's what we show with the functionality here. As you see that the biodiversity was low, the functionality is very low, and the resistance to stresses was low, meaning that if there was drought or some other condition, that the changes could happen easily in this crop. It's going to go into stress. And so that was immediately noticed, that we did improve that with the function of what Steve's products were putting in. If you go to the health part, you can see what we're measuring here is the actual disease pressure that we found. And a lot of times we go from mildly, or in this case, higher rates population of the species, even though we had, disease pressure still there, we did see that we had more of a lesser detected amount. So that was lowered, which means that we probably had more biocontrol agents, and that's going to be the next part below the health piece. If you look at the species we're looking for directly, down just a little up, just a little more alpha. Here you can see that we're looking for the biocontrol agents. In this case, so these are natural agents that help fight disease, help with bactericide agents, insecticides, and nematicides. We're not measuring in the case of nematodes, we're not measuring particular nematodes, we're measuring these biomarkers associated with nematodes. So this was an increase across the board with these natural agents that help build up better stress adaptation for the soil and for the plant. And then when you look at the hormone production, we went from, in this case, looking at, low, it's small here, but it was low across the board there on those three hormones versus what we brought it up to medium. And the stress adapters the same way. If totally overall, everything was improved by the addition of a biological program. You get down to the nutrients though, and that's where most people are focusing on. How did we do there? How do we get better improvement? So even though we went from very low to low, and that's why I like the BeCrop Test as a tool to show that with our heat map tools in our portal, you can now show the improvement overall. This went from very low pathways with nitrogen, phosphorus, potassium to low. Now, You might not think that's a lot, but when it comes to looking at, and then we have tools where we can actually show this index in 1% improvements, not in 20%. And in this case, we're looking at 20% improvement. So that's a substantial improvement when you go from very low to low. And then when you look at the minors, in this case, you can see here that we basically improved everything but calcium. Now, we don't know exactly with this report how much, but I would bet you if you look at once you get into our toolbox and see our comparative tools, that there was a substantial, probably a good increase in calcium as well. But overall, we had an improvement, and this is only just one season. What I like about the test is now we can measure this, indefinitely, as long as you're wanting to use the tools and measure your soil health. We have the tools now to be able to really improve that. Did these reports have the malic on the bottom?
I think so.
What did we see here with improvement in nitrogen?
Nitrogen.
Oh, this had a I'm trying to see, that's a malic 3, but we didn't have the ranges on it. But if you can look at the pounds per acre, 258, and phosphorus went to ppm 136 with a calcium 39. For some reason, our first one didn't have the ranges on low, medium, high. But overall, when you look at the biology, you can see that there was some substantial improvements. What was his crop performance, Steve? How did he do there?
As far as performance and yield, I can't share the number, but what I can tell you is it made a color change on the yield monitor, which everybody tells me is a substantial increase. He's asked me not to share that information, so I'm going to honor that wish. But it was a color difference on the yield monitor in the positive, to the point that he'd never done that high before.
Wow.
And this I've repeated 3 and 4 times across Michigan, Indiana, all the way to Georgia. This is just a normal thing for this to happen, is to see these type of increases.
Can you show the stress adapters, because that's the area that really we kind of overlook a lot of times when looking through these reports. But what I really like to note here is that these particular pieces of information are essential, because what we're looking at here, when you're looking at, for instance, exopolysaccharides, we're looking at the ability for that crumbling, the glue that holds the soil structure together. When you're growing mycorrhiza and you're trying to, and we measure that now with our new BeCrop 2.0 report, is that the functionality of that plant to store carbon in the soil happens between that interface between the fungal species growing on the root hair and the ability for the carbohydrates coming through photosynthesis from the plant to feed that, and then the exchange of the bacteria to give them nutrients. This symbiotic relationship is essential in understanding how plants contribute to carbon storage in the soil. So exopolysaccharide production is a major impact in how we can build better soil structure. When you're looking at heavy metal solubilizers, you're looking at the ability for the soil naturally to make heavy metals soluble, so they're not available to plants to pick up. What happens a lot of times is if the soil biology gets weak, the soil biology has an ability to protect us from these non-essential plant nutrients. And if you see that, there was some cases that have come out recently to where we're seeing, consumers concerned about the effects of heavy metals in their food source. There's a direct relationship between the soil biology and how these plants can absorb these nutrients, or not nutrients, but these metals. And so that becomes a major concern eventually, and it's going to be more and more of an observable index that we can now show if we make heavy metals more unavailable to plants as a nutrient. If they're not there, then you can think about aluminum, for instance. If that cation it's not preferred, it's not what the plant wants, but it will pick it up if there's no other nutrient availability. And then that becomes a problem, a toxin. Salt tolerance, it's the plant's ability to to stand up against salt conditions. The iodophore production, iron for the most part, when you see a total soil digestion, and I suggest that test for any farmer that's wanting to think about using biological inputs, is that total soil digestion will usually show you very, very high levels of iron. And the plant, through these organisms in the soil, have the ability to make these nutrients. It's a plant nutrients essential for health and plant life and for human life. Everything needs iron, soluble iron. This is how this is done. It's through the iodophore production. The ACC deaminase, when we're looking at the effect of ethylene and how that affects the plant's ability to pre-ripen. That's an amazing piece of information we can find here. Salicylic acid, when we're looking at that piece I talked about earlier, is that the plant can be in a condition of stress and produce salicylic acid. We want to be able to show that is a major, it's a hormone as well that we can now measure with with what we call our biomarker, and then the abscisic acid in that piece. So these stress adapters are essential, and it's an area that I go to pretty regularly when I look at a BeCrop test to see if they're indexes that were before we had this technology were never recognized, and now it's something that I really focus on when we're looking at impacts of biologicals.
All right, awesome. Thank you so much for that, Al. So before we jump into more of our Q&A, I wanted to speak a little bit about the importance of BeCrop advisors who, like Steve Fent, are able to, and Al for that matter, are able to read and understand these reports and really help growers really maximize on the nutrients that they already have, and to make sure that they are adding the suitable inputs that really actually address the needs that they have in their soil. So by becoming a BeCrop advisor, you can play a very big role in helping farmers with all of all of their management decisions. And BeCrop is a great tool to be able to understand the biology of the soil and to be able to make these decisions based on data that is visually presented in the way that that we are seeing here today. So we also run trials on BeCrop too. So for example, an input biological like Hello Nature's, we can run trials with before and after in a control and treatment blocks to demonstrate the effects of the input. And that is also another great tool to understand the effects of the input and the performance and the areas that any input can help with the soil functionality. And working with manufacturers to run the trials and working with growers to understand their soil really allows BeCrop advisors to be the bridge the gap between the soil needs and input performance. So that's the main idea, the big idea, the dream is that every soil gets exactly what it needs, and that is done through understanding the data that we have on soil biology. And we also have a BeCrop rate. So we have the BeCrop trials, which is for input performance demonstration. And we have the BeCrop Test, which is the report that we have been seeing today. And the BeCrop Plus is the malic that it gets added through our licensed partners such as Waters, Ag Labs, and others across the world that are able to provide the physiochemical or other types of tests to complement the BeCrop technology. So we have several licensed partners, and we are growing that as well. And BeCrop rate is to measure the sustainability of management practices. This is very exciting and new for us. We are, this is going to be more prominent for us later this year. But since you are all here to learn about the BeCrop, I wanted you to have sort of like a first exposure to this information that we are going to be using BeCrop rate in order to measure the impact of human intervention and assign a sustainability score. It goes from D to A++. That basically is a reflection of sustainable management practices, which is very exciting for us. And I hope that that gets to be utilized by farmers who want to demonstrate that they are growing their produce using sustainable practices, and food companies who want to source their produce from sustainably grown farms that are now verified, because we can look at the data, we can look at the biology, we can look at the functionality of the soil and how well it's being taken care of. So BeCrop Technology really brings all of these industry players together in order to it provides the standard to work with, that everybody can understand what they have to work with, and what their goals are and how to get there. So as BeCrop advisors, it's really crucial that, and some of you have already graduated from the program and are here to learn about how to put your certificate to good use. So this is just something that I wanted to highlight, and we can talk more about this. Feel free to reach out to myself or Al or Steve or anybody that, if you have any questions about that, or if you're excited and have ideas, love to work together. And yeah, so with that, I'd like to give some time for Q&A, maybe in an extra 3 minutes, because we have some really good questions coming in. So let's see, we have, what are the organisms that are related to each of these compounds? Al, did you want to speak on that?
Talking about the soil organisms, if they are, then we identify those in our portal. You can find those. You know, a lot of times we'll see a species count, and I didn't show that on the report, to be 600-700 different species in the sample. Traditionally, we aren't focused on the species particularly. What our unique technology offers is the functions. So we really focus on the functionality. You think about this in particular. Let's look at species specifically that are moving nutrients. Let's say nitrogen, for instance, in northern Michigan is not the same species that would be moving nitrogen or helping move nitrogen in southern Florida. So we don't want to just focus on species identifying those, even though we do have that. We want to focus on the functionality. That's what the BeCrop test is about.
Awesome. Thank you so much. And thank you so much for the quick answer, because we have so many questions to get through. I have another question. Where do you get SAP analysis done? And did you track with SAP analysis at the same time?
Yeah,
Steve, you can answer that.
I use a company in Michigan called New Age Labs. There is also NovaCrop in Europe, in Holland, that does it, and Apical out in the West Coast in Oregon also does SAP analysis. And the key is to whichever one you use is kind of like your soil testing, everything else, stick with that lab. Oh, and Waters has now started to do some SAP analysis also. They got into it, I believe it was last year. So we're learning along with them and helping them along. What was the second part of the question?
And did you track this with SAP analysis at the same time? I think they were talking about reports.
Yes, we the customer has the SAP analysis. He was the one getting them done, but we did track it through the whole season. Normally, if it's corn or soybeans and you want to do SAP, you can do like 4 tests. On the peppers, he did quite a few, like every other week, like he would his tissue, because he's spoon feeding a lot of the nutrients for fertigation. So there's protocols set up by each of the different testing companies. But the one reason I like SAP over tissue is SAP tells you what's going to happen in a week. You can identify it a week or two before it happens. And tissue is kind of like what's happened in the past, in the past couple of weeks. But if you've been doing tissue testing, like I know some guys have for 20 some years, they have a feel in their crops what their tissue should look like today at that stage. So I'm not going to talk bad about tissue. It's just SAP is a newer version, in my opinion, that just helps you identify some nutrient deficiencies or imbalances, maybe more importantly, the imbalances where it can lock nutrients up and they don't move through the plant.
Right. Thank you so much for that. Another question we have is, Al, can you explain how copper levels dropped, but the analysis suggested improvement in the pathways, I'm assuming?
I don't know exactly why. I mean, we did notice there wasn't much, very, very small amount, 2 ppm, but it didn't go up or down either one. What we noticed is that you know, and I don't know if that's what the effect of that was. I know over time that we've been able to watch that improvement with these minors, and you're talking about very minor amounts. We don't have the total answer. We just know that observable indexes that we saw here in this particular case at the copper level went down as far as the actual nutrient. I don't know if the plant was using that or what. Now the pathway is what we're measuring with the BeCrop test. So
Yeah, a lot of it is plant uptake.
We want to look at the ability for that soil to open up the nutrient pathway, and the copper pathway is what we want to observe. So the plant could have been using it, or other sources it could have been more soluble. So we don't know why that dropped just a little.
Okay, thank you so much. Next one, for this test, did you test just these 2 times? And if not, how many times have you sampled along the year and when? And maybe Al, if you want to give a recommendation as to what would be ideal after that would be great too.
So we're doing composite samples. So this farmer has a very large farm. He's got a few thousand acres. So we were looking at what we'd like to do is, in this case, is we want to do a management zone. In this case, I think this river farm was 40 acres, and we wanted to be able to do a composite of that. We would prefer to do 3 intervals, pre-season, application, let's say 15 days after the application of the in-furrow product, and then into the season to really be able to take these BeCrop reports and do heat map comparisons in our tool, in our portal, to be able to show the improvement. So what we understand that biology is really affected mostly by the irrigation practice and the farmers' cultural practices. There's not very much variability, and we've done some tests to show that on large farms, looking at comparatively 5-acre grid, let's say, BeCrop tests over a general, I would say, cultural practice or management zone. So we did composites in these fields. We did actually 9 different fields. So we had a lot of different samples we did, but we recommend 3, at least 3, if you're a farmer, 3 tests per season on a cropping system.
Awesome, thank you so much. So another question, because what is being measured is the organisms that secrete or promote hormones, how do we know that the plant is actually benefiting from this? Was a crop benefit in, say, yield or quality measured?
Conventionally, we've always thought of nutrients being the biggest influence on crop performance. We've never had a tool where we could actually show the effect of the soil biology. Soil is a digestive system. We have to think of it as a digestive system. So the way nutrients are absorbed into the plant, if it's not in a solution, if it's not in the soil solution, I'm talking about soluble forms, the plant really doesn't have a way to pick that up unless it goes through some sort of a biological digestive process. And so what we're trying to show here is that improving those organisms that actually help move these nutrients, and we call those a pathway. That's what we call those in our BeCrop test. If we open up this pathway, then we've opened up the ability for that plant to absorb more nutrients. And so that's the whole idea behind. Now we have a tool. You think about it, the plant exudate is actually mining through the biological interface the nutrients that it needs to survive. If it wasn't for this enormous work power of the soil biology, we would be wading neck deep in dead plants and tissues. I mean, the soil has a function that we really never focused on in farming before, and that function is the ability for nutrients to be moved through this biological interface. So I want us to kind of think differently. is that when you're thinking about corn, for instance, when there are now farmers that are planting 40,000 plants per acre, what kind of energy is the photosynthetic powers providing with providing carbohydrates to the soil biology from the plant going through the exudate? We don't only think about nutrients going up, we should be thinking about the ability for the plant to produce energy going into the soil. So let's feed that first. We gotta call that the primary pool. Feed that primary pool, and the secondary problems kind of go away. Secondary problems being the shredders, disease, insects, these other issues that really affect the plant, and we fight those, all the time when we should be feeding the soil microbiome. And so that's the energy is that the plant has is to actually help us as managers of cropping systems with this powerhouse of biology, if we could help feed that.
Awesome. Thank you so much. And you have time for just a few more. This one, what are all the different samples taken for a BeCrop test? What are the ranking index benchmarks for each crop or soil, etc., based on, for example, reference data or internal company data?
Both. We've done, I think, over 40,000 samples. We have a database of a lot of data, and these are all based on crop species, particular groups. And then we also have other data we collect from our bioinformatics team that's always looking to improve our library. We right now, I think, have 10 million species in our library, and it's growing daily. And so the functionality of these species is what we're really focused on, and that's the whole effort that our bioinformatics team's after right now. So we have, I think, 170 different crops that we look at, and each one is specific when it comes to our BeCrop test. So it's essential when we get a soil sample that we know the crop, we know the date, and we really want to know generally we want to know the GPS position or the location of where that sample is taken.
Right. Awesome. Another question: what crops do you work in?
A lot. I think we go. I always say from artichokes to zucchinis. We handle. I'm looking at reports regularly now. Our most common crops anymore seem to be the row crops. A lot of potatoes, a lot of corn, a lot of soybeans, a lot of citrus, a lot of specialty crops that we look at. Steve could probably answer that as well, because they've been looking at specialty crops mostly, but now they're in the row crop world.
Yeah. So, and trees.
Yeah.
From walnuts to like you said, citrus, pecans, about everything, every crop out there, plus turf. We're actually doing a lot with golf course now. And so that you can't count that out either. They're having the same issues there. How much nutrient do they have to put down with fertilizer prices? Guys are utilizing this tool to help them, figure out what they want, the best bang for their buck on their fertilizers.
Awesome, thank you. So we have one more we can have time for, I think. Let's see. Do BeCrop advisors get to see the result of the before and after biologicals test, so we can see for ourselves what is good to further suggest to growers? I'll go ahead and answer this one, and the answer to that is yes. So our BeCrop portal, which we're not going to go over that today, but BeCrop advisors, we will have some specialized training on using the BeCrop portal just for our certified advisors. So that will allow you to, it's a client management portal that you can look at the clients, you can look at different crops that they've done, you can look at different times, you can actually use the toolbox to, you know how we were putting some of those reports together, you can isolate specific metrics to compare across the 2 or more, up to 20 samples you can see from different locations, or you can choose the criteria that are different and see how that changes things. So there's a lot that the BeCrop portal can offer to further assess the results of these reports and understand what is happening in the soil. And we are now here at time, 10 o'clock sharp. Sorry we did not get to all of the questions today, but please reach out if you have any burning questions that you didn't get to ask, or if you didn't get to answer those questions, we'll do our best to make sure to get back to you. And thank you so much for joining us today. Al, Steve, did you want to say a few words before we close?
Thank you guys for letting us tell you our little story here, and we really think that we have a new tool. You know, I think about this all the time, is that in my career, 30 plus years in working in soil science, to have a tool that can actually now give recommendations on biological inputs is a major impact in agriculture, especially this year with the price of fertilizers. So we see now that we can actually solidly go after the nutrients that were unavailable before with this technology. So thank you all for attending, and Steve, always good to see you, and Ava as well.
Thank you so much.
Thank you everybody for attending, and reach out to Al or myself. Anybody will be more than happy to help you. I'm not here. A lot of what we did had other people's products in. It's not just ours. It's about helping, make the soils better and helping each individual farmer. So thank you. Thank you for letting me be part of this too. Appreciate it.
Thank you. All right. And with that, I think that we are finished. And thank you so much for joining, everybody, and have a great day.